Tangents to circles. In our previous video, we tackled angles in the same segment are equal. Angles at the center is twice the one on the circumference created by the same arc. Then cyclic quadrilaterals has opposite angles adding up to 180 degrees. Our objective in this video is to identify the tangent as perpendicular to the radius at the point of contact, and also verify that the angle between the tangent and the chord at the point of contact is equal to the angle in the alternate segment. Then we'll use this to solve two exam style questions. So let's begin. Now, these are not tangents because a tangent must touch the circle at just one point. When we extend this line, it will cut the circle again, so it's not a tangent. Here are examples of tangents to the circle center O. When we extend the lines, they will never meet the circle again, so they are tangents. When we draw a straight line from the center O to meet the radius, to meet the tangent, these straight lines are radii. Now, what is the angle between the tangent and the radii? What is that angle? That is what we want to find out. Now, when you draw the diameter like this to intersect at the center, and you draw a straight line at this point, from here to here is a radius. This is also a radius. So you see that these two lines, the tangents will never meet. They are parallel to each other, which means that they are all perpendicular to this line. So they are 90 degrees. The angle between the radius and the tangent is 90 degrees. This is just a simple trick to prove that the angle between the tangent and the radius is 90. We can also verify by measuring the angle using a protractor. So this is a radius, OP is a radius, QPR is a tangent. So let's measure with a protractor to verify. So you can see that the angle between the radius OP and the tangent QPR is 90 degrees. Now let's verify that the angle between the tangent and the chord at the point of contact is equal to the angle in the alternate segment, which is our second objective. So line DBE is a tangent and AB is a chord. BC is also a chord. This angle here, what is the value? So let's measure it and see. We use a protractor to measure it and realize that it is a 46-degree angle. Then let's measure the angle here too and see something. So this angle too is also a 46-degree angle. So which tells us that the angles in alternate segments, which is this angle and this angle, are equal. So the angle between the tangent and the chord at the point of contact here is equal to the angle which is in the alternate segment, which is remote or far away from this angle. So let me ask you, what would this angle be equal to? Yes, it will be equal to this angle here. You are right. So that is angles in alternate segments for you. Now let's shift the tangent from B to C So what is the value? Which angle is equal to angle ACD? Yes, you're right. This angle here, the one in the alternate segment. Then which angle is equal to angle BAC? Yes, it's this one. This angle here. Alright. So let us solve some questions with this property or theorems that we just talked about. So the first question is here. In the diagram, O is the center of the circle. AK is straight line and TK is a tangent. If angle CTK is 30 degrees, calculate angle TKC. Angle TKC. So this angle is what we are looking for. So you have to use angles in alternate segment. Because TK is a tangent, the angle that is here should be equal to this angle, as we just saw. So this is also 30 degrees. So if this is 30 degrees, then we can easily find angle CTK, because angle CTK, when we add it to the 30-degree angle here, and we add it to the whole of this angle, which is 90 plus 30 degrees, we are supposed to get the sum of angles in a triangle, which is 180 degrees. Sum of angles in triangle AKT. So angle CTK will now be adding to 30 plus 90 plus 30 will be 150 degrees. That will give us 180. So we subtract to get angle CTK to be equal to 180 minus 150 degrees, and that will be equal to 30 degrees. There's another way you could have done this. You could also find this angle here, which will be, this is 120, so this will be 60, so it means this is 60. So if this is 60, then this will be 120. So you can use 120 plus 30 plus CTK to also get the same value to be equal to 30 degrees. So angles in alternate segment, this and this are equal, whilst this and this are also equal. So we just have to use our knowledge of sum of angles in a triangle, in addition to the fact that angles in alternate segments are equal, to be able to solve this question. Let's take the second example. Here we have our second question. In the diagram, line segment TS is a tangent to the circle at S. If O is the center of the circle, angle TSP is equal to 21 degrees and angle RQP is equal to 100 degrees. Find with reasons angle SPR, then angle QSR. Let's begin with the I, angle SPR, this angle here. Now that angle is found in triangle SPR. So we can use that triangle to find the value of angle SPR. Recall that SPQR is a cyclic quadrilateral. Therefore, the opposite angles should be equal to 180 degrees when we add them. So angle PSR plus the 100 degrees angle should be equal to 180 degrees. So angle PSR is equal to 180 degrees minus 100 degrees, which is equal to 80 degrees. So this angle here is 80 degrees. So from triangle SPR, we can find this angle, which is angle SPR. Now, before then, we need to find the value of this angle using angles in alternate segment. Since TS is a tangent and it meets the chord PS at S, the angle over here should be equal to the angle here, which is the angle in the alternate segment. So angle SRP is also 21 degrees. So from triangle SPR, angle SPR plus the 21 degree angle. So that is the reason. The reason why we got here to be 21 degrees is angles in alternate segments are equal. So you can add that explanation. And when we add it to the 80 degrees, we have to get 180 degrees. The reason is that sum of angles in a triangle will add up to 180. So angle SPR, when we add it to 101 degrees, will give us 180 degrees. So angle SPR is equal to 180 degrees minus 101 degrees, and that will be equal to 79 degrees. Now that we found angle SPR, we can now find angle QSR. So this is 79, and when this is 79, this will be equal to this angle here, which is also 79 degrees. Angles in alternate segments are equal. So angle QSR, this angle here, this small angle here, when we add it to the 79 degrees angle, we have to get 90 degrees, because the angle between the tangent here and the radius OS should give us 90 degrees. Already this is 79, so this will be 90 minus 79 degrees. So angle QSR plus 79 degrees is equal to 90 degrees. So angle QSR is equal to 90 degrees minus 79 degrees, and that will be equal to 11 degrees. Thank you so much for all your support. If you want to support this channel, if you want to show your love, just share this video with your colleagues. And I'm very grateful for your support. Thank you.